There is a secret no one discusses, a silent limitation buried deep inside computers. For 70 years, every chip obeyed one rule, a rule so strict, nobody dared question it. That rule is binary, zeros and ones, two simple states ruling the digital universe. But here's the shocking truth. It's fragile. Binary wasn't destiny. It was an accident. An accident born from early machine design. Vacuum tubes and relays had only two states, on or off, yes or no, 0 or 1. So binary became the foundation of everything. But what if that was never the limit? What if our machines could go further? What if computers had not two, but three? Three choices, three states, three logic levels. This isn't science fiction. It's real history. And it began in the most unlikely place. Picture the Soviet Union during the 1950s. A nation racing head-to-head with America. On the surface, the Soviets were winning. They built Europe's first digital computer. They soon outpaced America's legendary UNIVAC. For a brief moment, Moscow led the future. But then reality crashed down hard. The United States had IBM mass-producing computers. Factories churned out thousands of powerful machines. Meanwhile, Soviet computers were hand-assembled, painfully slow. Parts were scarce. Funding was fragile. Optimism fading. At Moscow State University, frustration grew unbearable. Professor Nikolai Brusentsov faced an impossible challenge. Binary mainframes were locked away in government labs. Students couldn't touch them, couldn't learn from them. So Brusentsov searched for another way forward. That's when fate intervened. He met a brilliant mathematician named Sergei Sobolev. Sobolev introduced him to a radical system, not two states, but three. Ternary mathematics. It was like watching color explode into black and white. Suddenly, everything changed. Imagine a single unit of data. In binary, it carries two choices only, yes or no, light or dark. But ternary carries three possibilities, -1, 0, and +1. One unit now stores more information instantly. This wasn't just elegance. It was efficiency. Negative numbers no longer needed extra bits. Addition and subtraction became simpler, faster, cleaner. The circuits themselves required fewer components. Cheaper, smaller, easier to build from scraps. Brusentsov saw his opportunity. Together with his small team, he dared. After 2 years of relentless work, success. In 1958, the world's first ternary computer appeared. It was called Setun, a machine like no other. Setun wasn't powerful by today's standards, just 2,000 magnetic elements inside, barely 100 germanium transistors ticking away. But here's the twist that stunned the world. It cost 10 times less than binary machines. It used 30% fewer components overall. For the first time in history, ternary worked. 50 machines were built, sent to research labs. The Soviets had created a hidden jewel, a jewel that could have changed everything. But destiny wasn't kind. Production stopped before momentum could rise. The government refused to back scaling efforts, and the rest of the world had moved. Binary software, binary memory, binary transistors everywhere. The stack was locked. The choice already made. Setun faded into obscurity, not because it failed, but because politics killed it. A revolution buried beneath bureaucracy and history. Yet, the story doesn't end here. Today, the very wall Brusentsov saw returns. Artificial intelligence devours energy like fire devours oxygen. Data centers strain power grids across the planet. Binary might no longer be enough. And this time, Ternary is knocking again. Not in Moscow, but on a global stage. With advanced manufacturing and new materials rising, the ghost of Setun whispers once more. Could Ternary finally claim its moment in history? Stay tuned, because the answer will shock you. Every chip today is built on transistors, tiny switches, smaller than a human virus. Each transistor flips between two simple states. Cross a voltage threshold, it turns on. Drop below, it turns off again. This switching defines the entire binary world. Think of it like human patience. Annoy someone slightly, and nothing happens. Push too far, and boom, they snap. That's how binary transistors operate. One threshold, two results, nothing in between. But Ternary needs more than patience. Let's make this real with one example. The simplest component is the AND gate. In binary, it's childishly straightforward. 4 combinations. Only when both inputs are 1, output is 1. Every digital circuit depends on this logic. But in Ternary, things explode with possibility. Each input now has 3 choices: -1, 0, or +1. That's 27 unique combinations instantly. And the Ternary AND gate doesn't fail. It simply returns the lowest input value. This tiny shift changes everything. Suddenly, every line of logic becomes richer. More work gets done with fewer wires. More density means more power inside smaller chips. Huawei's patent data is jaw-dropping. 40% fewer devices required overall. 60% lower power consumption reported. 20% faster performance than current designs. And that's just from the first prototype. But here's where it gets tricky. Patents are only the visible surface. The biggest breakthroughs often remain hidden. Companies patent small parts, not the whole system. Which means there could be far more happening. More experiments, more secret prototypes, more surprises ahead. So why should you care? Because energy is the crisis nobody's addressing. Training AI today costs millions in electricity. Running massive data centers drains national power grids. Every chatbot, every model, every digital brain devours energy. And binary has reached its breaking point. Ternary promises salvation at scale. Imagine cutting power bills by 1/3. Imagine faster chips in phones and laptops. Imagine cooler processors inside every data center. That's the seductive promise of 3-state logic. But promises always hide obstacles. And Ternary's obstacle is brutal: reliability. 3 states demand absolute precision in circuits. Even the smallest noise can destroy accuracy. That's why new materials matter so much. Graphene, carbon nanotubes, and even exotic semiconductors. Their properties allow sharper thresholds, less error, more speed. They offer natural 3-state switching mechanisms, and they could finally make Ternary reliable. In fact, research papers already prove it. At 32 nanometers, Ternary nanotube chips appeared. They achieved 45% less area usage. They consumed 30% less power overall. For the same AI tasks binary chips handle. That's not evolution. It's a revolution waiting quietly. So who wins this race? China has patents, momentum, and manufacturing focus. Huawei's prototype is just the beginning. If scaled, it could dominate global computing markets. But America won't stand idle. Silicon Valley is full of stealth projects. Startups chasing exotic transistor designs in secrecy. Government labs quietly funding post-binary research. And giants like IBM, Intel, and Google watching. Because if ternary succeeds, binary dies slowly. Meanwhile, Europe sees opportunity too. Institutes across Germany, Belgium, and the Netherlands experiment. They aim for breakthroughs in carbon-based electronics. TSMC and IMEC are betting hard on graphene. The race is global, the stakes enormous. But there's more at risk than business. Whoever controls the next computing revolution controls the future. Artificial intelligence, national security, economic dominance all depend on chips. If ternary proves viable, the balance shifts overnight. And history shows one truth: revolutions never wait. Think back to Setun's tragedy, a brilliant idea crushed by politics and inertia. This time, the stage is bigger, louder, harsher. The world cannot afford to ignore ternary again. So here's the cliffhanger. What happens when AI finally meets ternary? A perfect storm of efficiency and intelligence. A storm that could rewrite everything we know. And that storm is already forming. Because the first true AI-optimized ternary chips are coming. And when they do, the world won't be ready. Imagine a data center the size of a city. Thousands of servers stacked wall to wall, each one glowing, humming, devouring electricity non-stop. This is the hidden cost of artificial intelligence. Every chatbot, every translation, every image generator feeds here. Binary logic makes this consumption unavoidable. Two states require endless switching back and forth. Every extra calculation multiplies the energy demand. That's why AI feels so expensive today. Why companies burn fortunes just to stay competitive. Now imagine those same servers rebuilt with ternary. Each chip processing more information per cycle. Each operation completed with fewer wasted moves. Power use slashed by a third instantly. Heat reduced. Cooling costs plummeting. Performance skyrocketing. That's the future researchers are chasing right now. And it's not just about efficiency. Ternary could unlock entirely new algorithms. Neural networks designed natively for 3 states. Logic circuits capable of blending digital with analog. Machines that think in richer, more natural ways. Because here's the deeper secret. Ternary sits between binary and analog. Binary is strict, only 2 states allowed. Analog is infinite, messy, powerful, but unstable. Ternary is the sweet spot in between, not rigid, not chaotic, but balanced perfectly. That balance could change how AI learns. Instead of endless yes-no decisions, machines gain nuance, subtler calculations, smoother training, faster convergence rates, all while using less hardware, less power, less cost. But don't be fooled. This isn't guaranteed. The transition would demand rewriting everything we know. Compilers, programming languages, operating systems, all rebuilt. Software ecosystems decades in the making overturned. An upheaval as massive as the PC revolution. And that's why many fear it. Giant corporations resist disruptive change. They have billions invested in binary infrastructure. Migrating would cost fortunes and create chaos. So expect resistance, denial, even misinformation campaigns. Yet history proves one thing: resistance never wins. When a technology is truly superior, it spreads. The internet spread. Smartphones spread. AI spread. And ternary, once viable, will spread too. The real question is, Who leads first? China, America, Europe, or an unknown startup? Whoever wins will control the foundations of AI. And control of AI means control of everything. Economics, defense, communication, even culture itself. So pause for a moment and imagine. Your phone lasting days instead of hours. Your laptop running AI tools seamlessly offline. National power grids finally catching a breath again. AI models trained 10 times faster than before. Entire industries transformed overnight by a new logic. That's not fantasy. It's within reach. The pieces are falling into place right now. Materials, science, nanotechnology, and AI all converging together. The storm is building, the momentum undeniable. And here's the twist of destiny. Ternary failed once because the world wasn't ready. Today, the world has no choice but readiness. Binary is running out of road quickly. Ternary is no longer optional. It's inevitable. The final question is simple but terrifying. Will Ternary save us or break us? Because every revolution carries both promise and peril. A tool that saves power can also surveil. A chip that trains AI faster trains it stronger. And stronger AI may not always be friendly. So we stand at the edge of history. The next great leap in computing is coming. And this time, the leap is ternary. The world ignored it once. It won't ignore it again. The only question left is, who dares first?